complex cognitive behaviors also have to be bootstrapped from experience. So let's think for a moment about learning to recall the memory for events. All the information about events is stored in cortical columns and neurons. So remembering what happened on some specific occasion involves finding some way to activate a group of neurons that together have a predominant recommendation strength in favor of verbally describing what took place. And again, as I've said many times before, neurons and columns individually don't know anything about events, and there's no genetic information that labels the combination of processes that will get from some initial activation to the desired activation that will be an episodic memory recall. So the brain has to somehow use genetic information plus experience to find a way to invoke the right combination of information processes when sensory inputs indicate that some event needs to be remembered. So with this architecture, this time including some parts of the hippocampal system, there are the usual visual and auditory areas, the association cortex areas included earlier, plus some cortical areas closely associated with the hippocampus that correspond with groups of cortical columns that expanded their receptive fields at the same time in the past. And of course there's the basal ganglia components, corresponding with various actions on the cortex to prolong activity, to indirectly activate, and so on. Now, as described earlier in the course, episodic memory recalls occur by sequences of cortical activation behaviors that lead, for example, from sensory perception of some trigger words to speech describing a specific event. But how can this capability be bootstrapped? If a small child is asked, "What happened at the zoo this morning?" hearing the words will generate populations of columns in various cortical areas. The child will have already learned that some verbal response to adult questions is rewarded, but doesn't know the brain processes that will lead to the appropriate response in this particular case. So the child's brain could almost randomly pick some process. It might be indirect activation on the basis of frequent past simultaneous activity, maybe result in describing what a zoo is. But if the child happened on indirect activation on the basis of simultaneous receptive field expansion, an appropriate verbal response might occur and be rewarded by the adult. If the adult offered a clue, like, "Did you see the monkeys eating?" then an indirect activation that led to a similar activation to the one generated by the adult words will be rewarded, another use of rewarding imitation. Eventually, different sequences of activations that often led to rewarded behaviors could be recorded in the cerebellum.